Hi, grade 7. This is a math video for page 506, which is a study guide and review, numbers 19 through 36. So I'm going to show you something related to the first three problems. Take a look up here, please. What if I wrote 5 more than 3 times a number is, how about 35? How would I write that in math form? Well, more than, whoops, I didn't write more than, I just wrote more than 3 times a number. This more than part, that's 5 plus 3 times a number, that's 3 times x. The is my equal sign, and my 35 is 35. Then I got x on this left-hand side. It's attached to a 3 and a 5. I got to get rid of the 5 first. So I'm going to subtract 5 from both sides because I got to get rid of the addition to the x before I get rid of the multiplication to the x. And I get 3x equaling 30. Then I'm going to divide both sides by 3. And when I do that, I get an x value of 10. So, similar problem for number 20, except you'll notice in number 20 they use the phrase less than. What if I had this problem? 6 less than 2 times a number is 18. How would you write that one out? 6 less than 2 times a number. Well, at first glance, you might think it's 6 minus 2 times a number. 6 minus 2x. But less than, remember, means flipping everything. So we've got to go 2x minus 6 equals 18. Is my equal sign, right? Is my equal sign. And then at this point, I'm going to add 6 to both sides. Whoops. And I get 2x equaling 24. And then I'm going to divide both sides by 2. And x ends up being 12 in that particular case. How about number 21? Do you remember what quotient means? I hope you do. Quotient is really just a division problem. Quotient is just a division problem. So if I write the quotient of a number and 3, how about added to 10 is 55. How would I solve that? Well, the quotient of a number and 3, that first part, the quotient of a number and 3, I'd go n divided by 3. Quotient of a number and 3, and then this added to 10 part, I'm going to add 10, and then is my equal sign, and 55 is 55. First step now? Well, I got to get this n by itself, and it's attached to the 3 and to the 10. Which one do I get rid of first? I'm going to subtract the 10 first. That gives me 45 on the left side and n divided by 3 here. What's the opposite of dividing by 3? Multiplying by 3. And when I multiply both sides of the equation by 3, I end up with an n value of 135. 135. Looking at 22 through 26, the tough one might be number 26, but I'm going to do some that are similar to a couple of those there. First off, how would I handle something like 23? I'm going to go with 4x plus 10 equals, how about x minus 5? X minus 5. Well, the first thing I'm noticing is that there's a term, here's a term, here's a term, and here's a term. There's 4 total terms. These 2 terms could be combined together because they're like terms, and these 2 are like terms. Okay, now let's get rid of that. And the first thing I'd probably do is I'd say to myself, you know what? I could get rid of some of this stuff here if I would remember to think about subtraction as being adding the opposite of the second number, first of all. And then why don't we just subtract an x from both sides to start with? If I subtract an x from both sides, I'm going to end up with 3x plus 10 over here, because 4x minus an x is 3x. And we still have that plus 10. And over here, we're left with negative 5. Because if I have an x, and I subtract an x from that, I have nothing left. So all I'm left with is the negative 5. Good. Let's get the x by itself here. And let's do that by, first of all, subtracting 10 from both sides. And if I do that, I get 3x equaling negative 15. Then I'm going to divide both sides of the equation by 3. And when I divide both sides of the equation by 3, I get an x value of negative 5. Hopefully that hits on the board. I think it does. So that's similar to 23. Similar to 23. Now, what makes 26 a toughie? Well, 26 is a toughie because you've got a constant, and then we're subtracting from it a variable. And that's not the way we normally see it. We normally see the variable minus a constant. Here we've got a constant minus a variable. And so we got to be careful about that. So the first thing I'm going to rewrite this problem, do it a little bit differently. It's going to be a similar looking problem, but it's not going to be the exact same answer. First thing I'm going to do is I'm going to change all these subtraction signs to adding a negative so that they're a little less confusing, because subtracting is the same thing as adding the opposite of the second number. Now what can I do? Well, look at this. I got a negative 3y here. What if I add a positive 3y to this side? Do you see how these would cancel each other out and I'd be left with 8? But what I do to one side, I also have to do to the other side. So I'm also going to add that same 3y to this side, and that gives me 10y plus a negative 10. Now, I still got to get the y by itself. So let's get rid of this adding of negative 10. What's the opposite of adding a negative 10? How about adding a positive 10? Isn't that the opposite of that? Yep. And when I do that, I get 10y equaling 18. Now what? I'm running out of room there. I'm going to divide both sides by 10. And when I do that, I get a y value of 1.8 when I divide both sides by 10. A y value of 1.8. Okay, so that's similar to 26. How about 27 and 28? 27 says a grade of 92 or better. What if instead it said something like a grade of 85 or less? How would I write that? I'd write the grade needs to be less than or equals to 85. Why did I write it that way? Well, the grade I'm looking for is going to be equal to 85, that's what this part says, or less than the 85. So my grade has to be greater or less than or equals to 85. Now, in the case of 27, that one says a grade of 92 or better. So I'm going to have to think about a different inequality sign there. How would I graph that? Well, because it does say to graph. Filled in circle at 85. What number is smaller than 85? That's this side of the problem, right? What's smaller than 85? Well, 84 is smaller than 85, right? So I'd shade this side of the line in this particular case. Go down to 29 through 32. Solve the inequality and check your solutions. Solve the inequality and check your solutions. Well, don't have to necessarily focus on the checking part as much. You can, though. That would be awesome. If I had this problem, how would I solve it? Well, how do I get y by itself? I'm going to get y by itself by subtracting 10 from both sides of the equation. And when I do that, I get a y value being greater than or equals to 0. That's the solution right there. Y is greater than or equals to 0. when you get down to 33 to 36, be careful. Remember that new rule about any time you multiply or divide by a negative number, you're going to flip the sign? Don't forget to bring that into play. So let me show you an example of that. If I have, say, 12x is greater than or equals to, how about 36, and if I have negative 12x is greater than or equals to 36, in this case, I would divide both sides by 12, and I would end up with this answer. But over here, I would end up dividing both sides by negative 12, and so I'd have to flip the sign, and I would end up with x is less than or equals to negative 3. Remember, the deal is, up here, I would divide by 12, right? And over here, I am dividing by a negative 12, and dividing by the negative number means I flip the sign. Okay, hopefully that's enough for y'all. Thank you.